Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good day everyone, and especially to Sir Adrian. So I'm here to discuss about dynamics of rigid bodies that tackles about chapter 11, chapter 12, and chapter 13. So before that, we have the chapter 11, which is kinematics of particles. So first is, as we all know that in engineering mechanics, we have two branches, which is the statics and also the dynamics. So for this video, we would like to discuss about the dynamics. So dynamics is the part of mechanics that deals with the analysis of bodies in motion. So it emphasizes that it refers to the bodies in motion. So, as we all know na, uh, we had been study about the statics that goes back to the time of a Greek philosophers. So, the first significant contribution to dynamics was made by Galileo Galilei in 1564 to 1640s. So, in order for us to understand what is dynamics is, for example, is the how the moon affects the ocean waves. So that's why it focuses on the bodies in motion. So we have the dynamics include. So first is we have the kinematics. So kinematics, which is the study of the geometry of motion. So kinematics also is the yes, it is the study of geometry of motion without the directly considering the forces or potential fields affecting the motion. So, in other words, kinematics is it focuses or examines the how the momentum of energy are shared among the interacting bodies. So, in kinematics, it focuses on the motion, which is it refers to the how the study of an object is given into motion. So the next one is we have the kinetics. So kinetics is the study of the relation existing between the forces acting on the body, the mass of the body, and the motion of the body. So as we all know that na yung kinetics, it focuses on the understanding of the different types of motions of any object. So uh, it also includes the rotational motion in which the objects experiences the force or torque. So, for example, is the friction, the gas kinetics, and also yung sinabi ko kanina, which is the torque. So, we conclude that ang kinetics is focuses on the motion with force. So, ang kinetics is motion with force, while the kinematics is it focuses only in motion. So, the next one is we have the mechanics. So, mechanics, which describes and predicts the condition of rest or motion of bodies under the action of forces. So, another definition of mechanics is a branch of physical sciences that deals with energy and forces that if that their effect on bodies. So, uh, for example, is the distance it takes for a car going 30 meters per hour to stop. So, it very understandable na yung mechanics is the condition of rest or motion kung saan nag-stop ang isang car or the distance of the car, which is we, where it takes for a car going to stop. So that's the mechanics. So uh, mechanics is divided into three parts. So we have the mechanics of rigid bodies. So mechanics of rigid bodies is the idealization of a body that does not deform or change shape, meaning the mechanics of a rigid bodies does not change the shape or the distorting. So that's the mechanics of rigid bodies. The next one is the mechanics of deformable bodies. So deformable mechanics of deformable bodies, which is the cause of a change of a dimension of a body structure. So uh, a very good example for this is the a bridge that does not deform under the weight of a single man, but it may deform under a load of a truck or 10 trucks, but the deformation is small. So the mechanics of deformable bodies. So the next one is the mechanics of fluid. So we encounter also the fluids, which signifies the surface tension, the pattern formation in boiling liquids. So mechanics of fluids also is a branch of physical science or physics that concern with the mechanics of fluid and the force on them. So mechanics of fluid is based on the behavior of the behavior at rest and in motion. So that's the three parts of mechanics. So the next one is we have the rectilinear motion of particles. We have the position, the velocity, and acceleration. So we have rectilinear motion. So rectilinear motion is a particle moving along a straight line. It is also defined as the linear in motion in which the velocity remains constant and also the path is a straight line. So it focuses in a gravitational forces of an object that resulting into free fall. So one example of a rectilinear motion is that the kids sliding down in a slide, wherein uh, it is a path of a straight line where the kids sliding down in a straight line. And also the motion of a plane is in the motion of the plane in the sky, wherein the velocity remains constant. So we have the average velocity of the particle over the time interval delta t is defined as the quotient of the displacement delta x and the time interval delta t. So uh, average velocity is just equals to the time interval, which I mean the delta x over the delta t, wherein delta x is expressed in meters and also delta t is expressed in seconds. So the average velocity, which is this one, is expressed in meter per seconds. So the instantaneous velocity v of the particle at the instant t is obtained from the average velocity by choosing shorter and shorter time intervals delta t and displacements delta x. So before that, instantaneous velocity is that the quantity that tells us how fast an object is moving anywhere along its path. So instantaneous velocity also simply called the simply velocity. So we have this instantaneous velocity formula where v is just equals to limit of delta t y 0 delta x and delta t, where delta x is the displacement and also delta t is the shorter time intervals. So the instantaneous velocity will also be expressed in meter per second or feet per second. Observing that the limit of the quotient is equal, by definition, to the derivative of x with respect to t, we write v is just equals to delta x over delta t, where the v is the velocity which represented by an algebraic number which can be positive or negative, which is yung v natin. It refers to the positive or negative algebraic expression that the result would be. So we have, yeah, in this figure, as we can see that our p is approaching to x-axis, wherein our v is greater than 0. Therefore, our v is indicates the x increases, where our vs increases, and also the our particles in this figure is positive direction, where it encompasses it the direction of this figure is in x direction. Therefore, it is a positive value. Then the next one is we have this figure where our p is approaches to negative, or the our x is approaches to decreases, where v is just less than 0. Therefore, a negative value of b indicates that our x is decreases. Therefore, our particles in this figure is moves in the negative direction. So for all of that, we have the magnitude of b is known as the speed of the particle. That's the instantaneous velocity. So the next one is we have the, so in this figure, this one, we consider the velocity of the particle at a time t, and also its velocity v plus delta b at a later time t plus delta t. So the average acceleration of this particle over the time is the interval or of delta t is defined as the quotient of delta b and delta t, wherein our delta b is just expressed in meter per second, while our delta t is expressed in seconds. As usual naman yung time natin is in terms of seconds. So therefore, the average acceleration will be expressed in meter per second squared. So in this figure, we can say that our average acceleration is simply defined in the velocity over the time, the time. So uh, in and also in instantaneous acceleration of the particle at the instant t, which is this one, is it obtains in the average acceleration that by choosing smaller and smaller values for delta t and also the delta v, this one. So that's the uh, average acceleration. So the next one is we have the uniform rectilinear motion. So as we all know that uniform rectilinear motion is a type of straight line motion which is frequently encountered in a practical application. In this motion, the acceleration a of the particle is 0 for every value of t. So the velocity v is therefore constant and it becomes this one. So our delta, our velocity, which is the v, is constant. So the position coordinate x is obtained by integrating this equation, that denoting by x sub o the initial value of x, we write this one, the integral of x and x sub o, which is delta b, is just equals to v integral of t and 0 which is yung sinabi ko kanina na uh, the acceleration of the uh, a of the particle is 0, then delta t. So we have x minus x sub o, then the integral of delta t, which is t, then b t, then therefore we come up with the value of x is just equals to x sub o plus the v, which is the velocity, then time. So the next one is we have the determination of the motion of a particle. So ito naman is yung pagkakaroon ng understanding about the motion of a particles. So but before that, we must define what is particle. So particle is not strictly two small particles, possibly as large as cars, rockets, or airplanes. So we do not know kung ang particles pa ito is dinidescribe siya kung maliit ba or malaki. For example is the earth. We do not know kung small particles ba ang nakapaloob ba dito or large particles. So we have also the motion of particles is known if position is known for all time. So a very good example of the motion of a particle is the motion of the ocean. Malalaman mo kung paano ang movement o motion ng isang ocean kung ito ba ay paabante ba or paatras ang kaniyang direction. So that's the motion of a particle. It describes the motion or, or the movement of an particles that uh, it's specifically defined about the how it the position of our particles involved in this situation. So we have also the three classes of motion. We have the acceleration given as a function of time, which is a is just equal to f of t, this one. And the next one is the acceleration given as a function of position, which is a is equals to f of x. And the last one is acceleration given as a function of velocity, where a is just equal to f of b, which is the function of velocity. So to understand these classes of motion, we have this example. So sample problem 1. The motion of a particle is given by the equation s is equals to 2t4 minus t cubed over 6 plus 2t squared, where s is in feet and t is in seconds. So we need to find the first is the distance when t is 2 seconds. Number 2, the velocity when t is 2 seconds. Number 3, the acceleration when 2 is 2 seconds. So first is the distance when t is 2 seconds. So we have this equation na nakapaloob doon sa problem natin na yung s natin is just equal to 2t4 minus t cubed over 6 plus 2t squared. So just simply distribute the t value, which is 2 seconds, in this equation. So 2 times where our t is 2 over raised to 4 minus 2 where our t raised to 3 over 6 plus 2 times our t is 2 raised to 2. So we calculate, and we have this 38.67 foot. So that's the distance when our t is 2 seconds. So the next one is the velocity when t is 2 seconds. Since this is our equation, and also that in velocity we come up, or we had been tackled about that our velocity is just equal to delta s over delta t. Therefore, close I mean cross multiply, wherein our v is just equals to the delta t is just equal to t, then delta s. So we have all, kay hinahanap naman natin dito is yung uh, time natin, which is yung time, yung t. So we have then the derivative or of this the equation of s. Kunin natin yung derivative niya, which is 8t cube, which is 2 times 4, then 4 minus 1 is 3, minus t squared, which is 3 minus 1 over 2 plus 4t. So this is the we need to find, or ito yung nakuha natin na equation in terms of this one. So when t is 2 seconds, distribute the value of t in this equation, then we come up with 70 foot per second. Ito yung velocity natin when t is 2 seconds. So the next one is the acceleration when t is 2 seconds, wherein wherein yung kanina natin dito is ito yung gagamitin natin na equation in acceleration. So we have v is equals to 8 t cubed minus t squared over 2 plus 4t. Since our acceleration is just equal to delta b over delta t, where our a in terms of t, which is delta b. So the derivative of the delta b, which is this one, kunin natin yung derivative niya, which is 8 times 3, 24, 3 minus 1, t squared. So, minus 2t over 2 plus 4. Therefore, our t for solving for t is 2 seconds. So, distribute the value of t in terms of this equation, itong nakuha natin, then we come up with 98 foot per seconds. So that's the one way in solving the three classes of motion. So the next one is the curvilinear motion of particles. So as we all know that curvilinear motion is the particles moves along the curved path. Then we have the position, vector, velocity, and acceleration. So curvilinear motion is when a particle moves along a curve other than a straight line. So yun nga yung sinabi ko kanina na ang curvilinear motion is curve yung uh, curve yung path niya, since it is other than the straight line. So curvilinear motion is just it emphasizes for us na when we heard curvilinear motion, it simplify curve yung kanyang particles or yung movement ng kanyang motion. So we have this figure. So we know that our vector are this one are joining the origin O and P. So that's our vector R. Since the vector R is characterized by its magnitude R and each direction with respect to the reference axis. We therefore yung magnitude R is naka-indicate siya sa ating reference axis, which is in the point P. So our vector R is referred to as the position vector of the particle at a time t. So naka-focus siya sa position ng vector in the particle at a time t or in seconds. So uh, in this figure, it emphasizes that our uh, magnitude or our vector r is just curve yung path niya in terms of this one. Yung which is naka-curve siya since it emphasizes the value of the origin O to the point P until to the point P prime. So therefore it is a curvilinear motion. So we can now move on chapter 12, which is the kinetics of particles, the Newton's second law. So we have the introduction. So first is Newton's first and third laws of motion were used extensively in statics to study bodies at rest and the forces acting upon them. So as we all know that in this chapter we will discuss about the Newton's second law of motion that can apply to the analysis of the motion of the particles, and also the uh, extensively in statics to study bodies at rest, which is in constant. And also, however, when bodies are accelerated, for example, when the magnitude or the direction of their velocity changes. So Newton's second law of motion is and focuses on the magnitude and the direction of the velocity. And also, it is necessary to use Newton's second law of motion to relate the motion of the body with the forces acting on it. So, it is understandable that it relates the motion of the body with or which indicates, or we can we can use first acting on it. So that's the second law of motion. So Newton's second law of motion can be stated as follows. So if the resultant force acting on a particle is not zero, the particle will have an acceleration proportional to the magnitude of the resultant and in the direction of this resultant force. So it simply means that the quantitative description of the Newton's second law of motion that can be changes the force that can produce on the motion uh, that can produce in a body or the acting on a motion. So it also stated that the time rate of change of the momentum of a body is equal in both magnitude and the direction of the force that imposed on it. So, yes, yung sinabi ko kanina na yung Newton's second law of motion is equal to the both magnitude and the direction to the force that we impose on it. So, that's the second law of motion. So, next is the Newton's second law of motion is best understood by imagining the following experiment. So as we all know that Newton's second law of motion is also known as the law of force and the acceleration, wherein according to the formula that the Newton's second law of motion, which is the net force is equals to mass times the acceleration. So from that figure, a particle is subjected to a force of F1, which is this one, of a constant direction and constant magnitude, which is F1. Also, they are both the same. Under the action of that force, the particle is observed to move in a straight line and in the direction of the force. So it simply means that this figure is they are determining the position of the particle kung saan kung saan naka direction niya and the magnitude. So it also in the position of the particles at various instances. So we find that this acceleration has a constant magnitude. So they are constant magnitude itong figure na ito. Then this figure, the B and C, if the experiment is repeated with forces F2, F3 of different magnitude or direction, we find each time that the particle moves in the direction of the force acting on it and that the magnitude A1, A2, A3 of the accelerations are proportional to the magnitude F1, F2, F3 of the corresponding force. So as we can see that this figure B is there are different magnitude or direction where iba yung uh, uh, iba yung direction ng isang particles which is in the upper cases, while in the figure C is yung there are also different magnitude or direction wherein in the lower cases. So they are different. These two figure B and C are they are different. They are different magnitude or direction compare sa ating figure A, which is they are both constant direction and also constant magnitude. So that's the different. And also we have this f1 over a1, which is this one is just equals to f2 over a2 is equals to f3 over a3 is equals to constant. So in this figure, this one, the constant value that obtained to the ratio of the magnitude and also to the force and acceleration, that the characteristic of the particles. So it is considered also that these accelerations are under the consideration of the what we call the mass, which is the particle moves in the direction of the force, which is the mass. So the next one is the mass. So the mass is the constant value obtained for the ratio of the magnitudes of the forces, and acceleration is a characteristic of the particle under consideration. So as we all know that mass is a qualitative measure of the inertia or the fundamental property of all the matter. So that's the mass. Everything we can see around us has a mass. So one way that we can understood what is mass is that the amount of matter that represent in any object or in any object of the body. So that's the mass. So we have this equation 12.1 in related to the mass, which is the force is equals to mass times the acceleration. So when a particle is subjected simultaneously to several forces, equation 12.1 should be replaced by the summation of F is equals to ma, where summation of F is represent the sum or the resultant, this one, on of all the forces that acting on the particles. So that's the summation of F. Then we have also the linear momentum of a particle, rate of change of linear momentum. So but before that, linear momentum is also called the assembly momentum or the translational momentum. So as we all know that linear momentum is the product of the mass and also the velocity of the object. So it is also a momentum that is directly proportional to the object of the mass and also its velocity. So when we heard linear momentum is we simply defined by the product of the mass and also the velocity. So that's the linear momentum. So replacing the acceleration a by the derivative dv over dt in equation 12.2, we write the summation of f is equals to m, which is the mass, delta b over delta t. So since the mass m of the particles is constant, so we have this formula of 12.3 summation of f is equals to d over dt times mv, where our mv is called the linear momentum. Yun nga yung sinabi ko kanina na yung linear momentum is uh, the product of the mass and also the velocity. So uh, and also that, so in this figure 12.3, we can say that this figure has the same direction as the velocity. Yes, makikita naman natin na yung velocity niya is they are same direction as the particles, and the and each magnitude is equal to the product of the mass and also the speed, yes, of the particles. So they are equal or they are the same direction yung figure natin dito. So this also equation represents that the resultant of the force acting on the particle is equal to the rate of change of linear momentum of the particle. So they are also same with the linear momentum that you use in this figure. So in this form that the second law of motion was originally stated by the Newton second law of motion. So that's the uh, linear momentum of a particle. So next one is about the system of units. So we have two system of units that been discussed in this chapter. So two systems of consistent kinetic units are currently used by American engineers: the International System of Units, or the SI units, and the system of US customary units. So first is the International System of Units. So in this system, the base units are the units of length, the mass, the time, and are called respectively the meter, the kilogram, and the second. So International System of Units is also commonly known as the metric system. Ito yung kasagaran na ginagamit natin sa mga uh, uh, system natin. So, International System of Units provides us the definition of units of measurement that are widely accepted in science and technology, which set measurement standards agreed to through the Convention of the Meter, a diplomatic treaty between 54 nations. So they had been used to different nations, this international system of units. So the next one is the US customary units. Most practicing American engineers still commonly use a system in which the base units are their units of length, force, and time. So these units are respectively the foot, the pound, and the second. So US customary units is the main system of weights and measures used in the United States and few other countries. So uh, kasagaran naman yung gumagamit dito is they are the few other countries that had been practicing these American engineers that commonly used in a system. So the next one is we have these equations of motion. So but before that, what is equation of motion? So equation of motion is the mathematical formula that describes the position, the velocity, or the acceleration of a body. So, so from this figure 12.8, it describes that we consider a particle of mass, which is this one, the mass m, that acted upon by several forces, which is the first one and the first two. So we recall from section 12.2 that Newton's second law can be expressed by the equation, this one. The summation of F is just equals to mass times the acceleration. So they are considered as the equation of motion since it related to the mass and acceleration. So which relates the forces acting on the particle and the vector aim, which is the mass and acceleration. So uh, therefore we can conclude that the this figure, which is the particle of mass that uh, acted upon by several force, is just equal to the Newton's second law, which is the 12.2, which is expresses as the forces acting on a particle, which is the mass and acceleration. So the next one is we have the dynamic equilibrium. So dynamic equilibrium is the particle may thus be considered to be the in equilibrium under the given forces and also the inertia vector. So returning to equation 12.2, which is yung kanina, this one, this one, that transposing the right hand member, we write Newton's second law in the alternative form. So this one. So this figure expresses that if we add the vector, which is this one, which is yung kanina is ito yung mass and the acting forces, which is yung first one and first two. So in the dynamic equilibrium, for example, is if we add the vector minus mass times acceleration to the forces acting on the particle, we obtain a system of vectors that equivalent to zero. So we it is easily for us to understand that dynamic equilibrium, that if we add the vector, which is the negative mass times acceleration, then therefore our system of vectors are equivalent to zero. So the vector negative mass times acceleration of magnitude ma and of direction opposite to that of the acceleration is called an inertia vector. So as we all know that inertia is the property of matter that causes it to resist changes in velocity, which is the speed with the direction. So that's the inertia of vector. So a very good example of the dynamic equilibrium is that the aeroplane flying at the constant speed. So the aeroplane is being uh, flying at constant speed since they had been the mass and the acceleration, that the forces acting on that object is constant, which is they are not uh, the forces that acting on the particles are being expressed in the uh, are being expressed or are being uh, used in that second law of motion. So that's the dynamic equilibrium. So the next one is the equation of motion in terms of radial and the transverse components. So we have this: consider a particle of P of polar coordinates R and U, which is this one, which moves in a plane under the action of several forces. So resolving the forces in and the acceleration of the particle into radial and transverse components of figure 12.14 and
and substituting into equation 12.2, yung nakuha natin kanina, we obtain the two scalar equations. So we have these two scalar equation, which is summation of force in terms of r polar coordinates of r is equals to mass times acceleration raised to, I mean, in the polar coordinates of r, and also the summation of f force of polar coordinates of u is equals to mass times acceleration in terms of u. So these are the two scalar equation that could be used in the equation of motion in terms of the radial and transverse components. So we have also the motion under a central force, conservation of angular momentum. So as we all know that conservation of angular momentum is the physical property of a spinning system such that its spin remains constant unless it is acted upon by an external torque. So external torque is that, for example, na when you are screwing your feet to the ground. So they are external torque na nangyayari sa position na yon, which is yung screwing your feet into the ground. So that's the external torque. And also that example of the external torque is that the object changes in each shape. So when we say external torque is nag-change yung uh, changes or objects of the uh, particles, which is rotational inertia na nangyayari. So when the only force acting on a particle, so in this uh, uh, figure is that when the only force acting on a particle P, which is this one, is a force F, which is directed toward or away from a fixed point 0, O. So the particle is said to be moving under a central force. So in this time na, there are particles na nangyayari in terms of P to the F, which is the central force. So that's the acting on that particle. So the point O is referred to as the center of force. So tinatawag itong center of force. Since the line of action of F passes through O, we must have this one at any given instant. So substituting into equation 12.19, so therefore we obtain this formula, which is uh, this one for all values of t and integrating in t. So our h sub o is equals to constant. So we conclude that the angular momentum of a particle moving under a central force is constant in both magnitude and direction. Yun yung sinabi ko kanina na yung conservation of angular momentum ay they are concerned or similar to the both magnitude and direction. So that's the conservation of angular momentum. So we have also the Newton's law of gravitation. So in his law of universal gravitation, Newton states that two particles of masses, which is the big letter M and the M at a distance r from each other, attract each other with equal and opposite forces F and 2F, directed two forces directed along the line joining the particles. So the common magnitude force of the two forces is this one, this formula, which is force is equals to gravity times the mass of object 1 and a mass times the mass of object 2 over the distance between the centers of the masses. So this is the Newton's law of gravitation. So where our g is the universal constant, which is called the constant of gravitation. So the next one is the Kepler's law of planetary motion. So Kepler's three laws of planetary motion can be stated as follows. So first is each planet described an ellipse with the sun located at one of its foci. So from the first uh, Kepler's law of planetary motion is that as we all know that ellipse is like a circle which has been squashed in one direction. So according to him, that Kepler's analysis, in every planet has an orbit like the sun, which is not the center of the orbit. So all planet has an all planet move in an elliptical orbit with the sun. So we all know that the the planets in the universe move in elliptical orbit. So the next one is the radius vector drawn from the sun to the planet sweeps equal areas in equal times. So it means that the speed of the each planet changes depending on where it is in each orbit. So nangyayari lamang ito pag ang speed ng planet ay nakadepende sa kaniyang orbit. So as we all know also that considering the orbit of the planet, that it takes 1 year for Earth to complete the revolution around the sun. So the next last one is the squares of the periodic times of the planets are proportional to the cubes of the semi-major axes of their orbits. So it means that the square of the periodic times of the planets is that is how long it takes for a planet to complete the one orbit around the sun. So in that case, the Earth's the Earth has 365 days.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good day everyone, and especially to Sir Adrian. So I'm here to discuss about dynamics of rigid bodies that tackles about chapter 11, chapter 12, and chapter 13. So before that, we have the chapter 11, which is kinematics of particles. So first is, as we all know that in engineering mechanics, we have two branches, which is the statics and also the dynamics. So for this video, we would like to discuss about the dynamics. So dynamics is the part of mechanics that deals with the analysis of bodies in motion. So it emphasizes that it refers to the bodies in motion. So as we all know now, uh, we had been study about the statics that goes back to the time of a Greek philosophers. So the first significant contribution to dynamics was made by Galileo Galilei in 1564 to 1640s. So in order for us to understand what is dynamics is, for example, is the how the moon affects the ocean waves. So that's why it focuses on the bodies in motion. So we have the dynamics include. So first is we have the kinematics. So kinematics, which is the study of the geometry of motion. So kinematics also is the yes, it is the study of geometry of motion without the directly considering the forces or potential fields affecting the motion. So in other words, kinematics is it focuses or examines the how the momentum of energy are shared among the interacting bodies. So in kinematics, it focuses on the motion, which is it refers to the how the study of an object is given into motion. So the next one is we have the kinetics. So kinetics is the study of the relation existing between the forces acting on the body, the mass of the body, and the motion of the body. So as we all know that na yung kinetics, it focuses on the understanding of the different types of motions of any object. So uh, it also includes the rotational motion in which the objects experiences the force or torque. So, for example, is the friction, the gas kinetics, and also yung sinabi ko kanina, which is the torque. So, uh, we conclude that ang kinetics it is focuses on the motion with force. So, ang kinetics is motion with force, while the kinematics is it focuses only in motion. So, the next one is we have the mechanics. So, mechanics, which describes and predicts the condition of rest or motion of bodies under the action of forces. So, another definition of mechanics is a branch of physical sciences that deals with energy and forces that if that their effect on bodies. So, uh, for example, is the distance it takes for a car going 30 meters per hour to stop. So, it very understandable na yung mechanics is the condition of rest or motion kung saan nag-stop ang isang car or the distance of the car, which is we, where it takes for a car going to stop. So that's the mechanics. So uh, mechanics is divided into three parts. So we have the mechanics of rigid bodies. So mechanics of rigid bodies is the idealization of a body that does not deform or change shape, meaning the mechanics of a rigid bodies does not change the shape or the distorting. So that's the mechanics of rigid bodies. The next one is the mechanics of deformable bodies. So, deformable mechanics of deformable bodies, which is the cause of a change of a dimension of a body structure. So, uh, a very good example for this is the a bridge that does not deform under the weight of a single man, but it may deform under a load of a truck or 10 trucks, but the deformation is small. So the mechanics of deformable bodies. So the next one is the mechanics of fluid. So we encounter also the fluids, which signifies the surface tension, the pattern formation in boiling liquids. So mechanics of fluids also is a branch of physical science or physics that concern with the mechanics of fluid and the force on them. So, mechanics of fluid is based on the behavior of the behavior at rest and in motion. So, that's the three parts of mechanics.
So we have also the potential energy. So as we all know that potential energy is an object that can store energy as a result of each pulsation. So consider this figure 13.4. So from this figure, let us consider again a body of weight, which is this one, which moves along a curved path or the curvilinear motion, which is nakikita natin na yung curved path from point A1 of elevation, which is this one, to a point A2, which is elevation of y2. So in this figure, it stated that the potential energy is stored in this path, this one. Then after that is that the potential energy of an object is being uh, moves along a curve of a1, which is the elevation of y1. So therefore, and we have equation 13.14, which is this one, which is yung y1 2 is equals to weight of y1, this one, minus ng weight ng y2, this one. So we have also the work of weight may those be obtained by subtracting the value. So, yun nga, isubtract natin yung value of the function y, weight of y corresponding to the second position of the body from its value corresponding to the first position, this one. So, we have the work of W is independent of the actual path followed. So, naka-independent yung value or yung actual path ng ating work. So, it depends only upon the initial and final values of the function of weight y. So, this function is called the potential energy of the body with respect to the force of gravity. So, a very good example of an potential energy is that a spring has more potential energy when it is compressed or stretched. So, nagkakaroon ng malaking potential energy ang isang object if nagkukompress siya or stretching yung isang object. So, that's the potential energy. So, we have also the conservation of energy. So, as we all know that conservation of energy states the amount of energy which is neither created nor destroyed. So, such as the weight of a particle or the force exerted by a spring can be expressed as a change in potential energy. So, naka depende lang siya kung ang isang object is exerted by a spring. So we have also this equation 13.24, which is T1 plus V1 is equals to T2 plus V2. So this formula 13.24 indicates that when a particle moves under the action of conservative forces, the sum of the kinetic energy and of the potential energy of the particle remains constant, which is the sum of T plus V is equal to the total mechanical energy of the particle, and it is denoted by E. So, one example of the conservation of energy is when we roll a toy car down a ramp and it hits a wall. So the energy being rolled to a toy car is transferred from kinetic energy to potential energy. So that's the conservation of energy. So let's proceed to the principle of impulse and momentum. So as we all know that principle of impulse and momentum is the third basic method on dealing with the solving problems with the motion of particles. So this method is based on the principle of impulse and momentum and can be used to solve problems involving the force, the mass, the velocity, and the time. So uh, consider a particle of mass m acted upon by a force which is we saw in the section 12.3. Newton's second law can be expressed in the form of this figure. I mean this equation. the 13.27, which is force is equals to d over delta t dt, which times the mass times the velocity. So where our mv is the linear momentum of the particle. So since the it states that the impulse and the momentum of an object equals to the impulse that applied to it. So the impulse momentum theorem equivalent to the Newton's second law of motions. So that's the principle of impulse and momentum. So we have also the impulsive motion. So impulsive force, a force acting on a particle during a very short time interval that is large enough to produce a definite change in momentum. So impulsive force is a good example is that dropping a ball. So we know that when we dropping a ball from a certain height na uh, mangyaring ito na it bunches the ball into floor. It hits the ball into floor. So that's why the force that acting on the ball is impulse to the hits in the floor. So the momentum that developed by the ball suddenly turns to zero since it hits in the floor. So that's the impulsive force. So the next one is the impulsive motion, which is the resulting motion. So impulsive motion also is the term that is used to describe or quantify the effect of force acting over the time to change the momentum of the object. So that's the impulsive motion. So one example of the impulsive motion is when the ball is the baseball is struck. So we all know that a baseball have a bat and a ball. So when a ball and a bat takes place during a very short time interval, which is the delta t, when it struck, then the average value of the force is exerted by the bat on the ball. So nag-extract siya, which is the bat and the ball. So then the bat on the ball is very large and the resulting impulse of the ball is, which is this one, is large enough to change the sense of motion of the ball. So therefore, uh, yung yung ball ng isang bat is nag-extract siya sa work, which is the delta t is just equals to 0. So therefore, uh, we have now the mass of v2. So that's the impulsive motion. So we have also the impact. So impact is a collision between two bodies which occurs in a very small interval of time and during which the two bodies exert relatively large forces on each other. So this figure shows that line of impact. So line of impact is the common interval or the common normal to the surfaces in contact during the impact. So for example is that the a bat is striking a ball. So as we can see that this circle, uh, the velocities of the two particles are directed along the line of impact. So makikita man natin na yung direction ng kanyang velocity is along the line of impact, which is they are both similar to the direction. So this impact, which is these two particles, is said to be a direct impact, which is direct central impact, when the two bodies moving along the same line. So they are the same line moving. So they are easily collide the impact of the of these two particles. So this could be the direct impact, the which is the it moves along the same line. So that's called the direct impact. So the next one is the oblique central impact. When two either the both particles move along a line other than the line of the impact, so the line of impact is said to be the oblique impact. It is because when the direction of motion, which is yung direction ng each motion is one or both of the particle is at an angle to the line of impact, which is yung both ng kanilang direction is at an angle. So that's the oblique impact. So in impact, we can say that they are very common normal that uses the contact during the impact. So that's why we should always uh, we should always bear in mind that when two particles are being collide to each other, they are very, I mean, they are both directed along the same line. That we call the direct impact, while the oblique central impact is that the line of the impact is at an angle, or the movement of the particle is at an angle of each direction. So that's the impact. So thanks for listening, and God bless us all. Thank you.